Okay. The other thing we're going to look at is mass. What do you understand by mass? Okay. So mass is the quantity of matter in a substance. Remember to say the keyword here is what is matter. If you are able to understand matter in any way it comes, matter is anything that occupies space. So if you are able to understand that, then you are good to go. Okay. So here, the SI unit for mass, it is kilograms, which is also abbreviated as kg. Okay. So here we're having the formula. How do we derive into mass, or how do we solve for mass? So mass, it is mass is equals to weight times gravity. Okay. And another thing you and I are supposed to consider as we deal with mass, mass does not change from place to place. Remember, we are having gravity on Earth, which is 10 Newton per kg. On the moon, we're having 1.67. Okay, and on the outer space, we're having 0. But with mass, it does not change from place to place. If mass is 10 kg, even on the moon, on Earth, or outer space, it is still going to be there. So take note of this point, because this is actually where we make common mistakes. You may be tempted to leave out this one. So mass, if you are given mass in equation, do not solve for it. Just get the same mass you've been given. Okay, we're actually going to look at that. Okay, so and the instrument that is used for mass is beam balance. Okay, we are now going to look at force. What do you understand by force? Okay, so force is the pull or push of an object's mass and velocity. So the key point here, or just what you're supposed to take note, is that the pull or push of an object. So that is force. Okay, so I think you've even heard people saying force exempted on a car, the pushing of a car. That is force. Okay, so here we're going to look at the SI unit for force. What is the SI unit for force? The SI unit for force is Newton. Okay, having looked at the SI unit, we are going to look at the formula. What is the formula? The formula for force, force is equals to mass times acceleration. Okay, so having looked at this, we're also going to tackle on something that is mostly actually looks up to or brings mostly. So with here, I expect you to pay extra attention. Okay, so the laws of motion. The laws of motion that are applied in force. We have 3 laws. Those are what? Kelvin's laws. We have 3 laws. We are having one which says an object at rest remains at rest. An object in motion remains in motion unless acted upon by external force. That is the first law of what? Of motion. That's Newton's law. Please take note of that. The second one we are going to look at is that the force exempted on an object, it is equals to its mass times its acceleration. Okay. So it also says to say the force applied on an object is equal to its mass times its what? Acceleration. So here the key is only knowing the formula for force, and you'll be able to identify. Okay, so here we say the second law, or the second law of the laws of motion, the second one is force applied on an object is the same as its mass times its acceleration. The only secret here is to know the formula for force, and you'll be able to have the answer with you there. Okay, here we're going to look at now the third law of Newton, which says for every action there is an equal and opposite reaction. For every action there is an equal and opposite what? Reaction. Not forgetting to say these are what? Newton's laws. They mostly tackle on this. Okay, so having looked at this, we're actually going to look at a practical examination question paper that was actually written by your friends. Okay, so we're going to look at that.